Hello dear friends, I am Atikur Rahman. I am teaching at the Department of Geography, Jamia Millia Islamia, New Delhi. Today we are going to learn about the topic which is very important in today's context, that is Global Navigation Satellite System, GNSS, which talks about the global positioning system in common world. What we have, the learning objective of today's lecture is we are going to understand what is GPS, what are different countries which are operating this satellite system, and what are the different component of GPS, what are different segments of GPS, what are different data of GPS, and how we are capturing the data, what are different signals which are used for GPS satellite system, how they are controlled and how they are managed, and what are different application of GPS, which is very common in today's day-to-day life, especially in the urban areas. So, what we have, this system was started long back, say sometime in 1973, and different satellite was launched by United States in different phases. Initially there were 4 satellites that was launched, that was called experimental satellite, then another 4 satellite was launched as a developmental satellite, and they keep on launching different satellites, which we call as a satellite system, which is covered in the topic of today's lecture, that is called Global Navigation Satellite System. So, what we have, this system was basically started in 1973 and the full operation capacity was achieved sometime in 1975, sometime in July 1995. So, what we have, from then onwards we have started using different data, and the data that is about the physical and natural features of the earth's surface, wherever on any parts of the surface of the earth. So, once I say the physical feature and natural feature, that will come, that I will talk in detail in little later. So, let us talk about the system, the navigation system, what we have, navigation system. So, as I said that this satellite system was started in 1973. So, as of now, when we achieve the full operation capacity, there are 24 satellites altogether which are orbiting the earth. If you see these 4 satellites, these 24 satellites, sorry, there are 6 orbit, and in each orbit there are 4 satellites. So, that all comes together 24 satellites. So, if you see these satellites, there are 21 satellites which are active satellite, and there are 3 satellites which are active spare. At a time when there is any eventuality that if any satellite stop working, then they start operation of the active spare satellite. So, these satellites are placed at an altitude of more than 20,000 kilometer above the surface of the earth, and the satellites are designed in such a way that they are inclined to an axis of about 55 degree. So, if you stand on any part of surface of the earth in anywhere throughout the world, whether it is a remotest dense forest, or if you have a mountain, desert, or water bodies, ocean, at each and every point you will get the signals from these satellite system. Now, let us talk something about the system. If we talk about this global navigation system, they can be classified into 3 categories. One is called space segment, second is called user segment, and third is called control segment. So, we will talk in this lecture each segment in detail. Now, let us talk about why we need to today understand, why there is a need to understand and learn the GPS system. What are the advantages of this system? So, if I put it in a bullet point, because of time I will talk little in short. So, as I said that one of the most important advantage of this system is that you can acquire the data of any human or natural features on any part of the surface of the earth without any intervention, without any delay, without any hindrance. So, that means the data or the availability of signals is there on all parts of the earth. Number 2, it is all day and night operation. That means you can collect the data in the day, in the night, in the rainy season, in the cloudy season, any time. So therefore we call it all day and night operation. So you can acquire the data throughout the year without any problem. Third most important advantage of this system is that signals which are being used in this GPS system, I will talk on the signal system little later in detail. Signals are free, that means you do not need to pay any cost of data acquisition of any part of the surface of the earth. So signals are free. Another fourth very important the advantage of GPS is that you can acquire the data at a very precise level and also a little bit coarse. So what we have, as per your need and requirement, depending upon a need and requirement, you can acquire the data using global navigation satellite system that we commonly call as global positioning system, GPS. So as per your need and requirement, you can collect the data. For that you can use different instruments that we will talk in the end of this lecture, that what are different types of GPS satellite system and what are different GPS receivers which we use for data acquisition. Another very important is that when you acquire the data, if you want to acquire the data in a very precise mode, for that there is another system that we have to use two GPS that we call as differential GPS. We will talk little later about it. Now another very important issue is that the only issue what we need to be careful is that GPS, as I said, the signals are free, but it works with the line of sight. If you go inside any building, any room, and if you go inside a tree, what will have? You will not get the data. So for that you need to have in a position that you are directly, your instrument, that is GPS receiver, is directly connected with the satellite. So for that the sky should be open, you should be within the open sky, so you will get the data. So these are the very important issues that one need to understand. Now let us understand different segments of GPS, and I said that the very first and the most important segment is a space segment. Space segment consists of, as I talked little before, that it consists of 24 satellites which are orbiting at a different speed, which is about 7,000 miles per hour. These are inclined at an axis of about 55 degree. So these are designed in such a way that the satellites are moving in its fixed orbit all the time, day and night, and if you stand on any part of surface of the earth, what you get? You will get the signal from at least minimum 4 satellites. Now let us understand why 4 satellites. The reason being, in a very simple word, GPS gives you the data of any object, as I told you before, whether it's human and natural features. The data what we get is in the form of X, Y and Z, 3 dimension. When we say X, latitude, Y, longitude, and Z is altitude. So what you get? You get the precise positioning of an object. Let us say there is one tree, so this tree is on some particular part of surface of the earth. So what we have, if you want to know the location of this tree or any building, any object, you need to have a coordinate that is in form of X and Y, latitude and longitude. So what you have, if you get the latitude and longitude, you can say this particular object is precisely there, and that is the most important objective of this system, to know the precise location of any object. So I must tell you that this system was designed and developed by country United States, by the United States Department of Defense. Basically this system was designed and developed for military purposes, but later on it slowly changed into civilian uses. So our concern is how we can use this data for the civilian purposes, for the different planning purposes, for different projects. We will talk little in detail. in the later part of this talk. So, what we have, you need to get the x and y and z, that is altitude, that is height. If you want to know the height of any object, that you also get. So, till today, before the development of the system GNSS, we did not had any data on altitude. We do have a data of altitude by using satellite data, lidar data and all, but that is another field. So, what we get, the precise location of an object. So, location is so important, therefore, we need to have the GPS data. So, in a space segment, as I said, that if we stand on any part of the surface of the earth, whether you stand here, 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 you get at least signal from 4 satellites. 4 satellite. So, I was talking why 4 satellite. One satellite gives you x dimension, another gives you y dimension, and the third satellite gives you the z dimension. Another 4 satellite to cross check the values of x and y and z, in other words, to validate. So, therefore, as I said, if I stand in India, in Delhi, in Bangalore, in Madras, or in America, or any parts of the earth, we get at least 4 satellites which are being locked. So, what we have, let me tell you in beginning that the GPS receivers are just like a mobile instrument. So, what we have, that once you switch on your instrument, GPS receiver, you start getting signal from different satellite. So, what we have, if we stand here, you start getting signals which are above the horizon, You start the satellite which, as I said, that they are orbiting around the earth, you start getting signal. The more it goes above the horizon, more better you get the signal. So, in the meantime, once you switch it on and if you stand for some period of time, what you have, you start getting signal from different satellites. So, to get any location data, you need to have at least 4 satellites. The more the satellite, better the data. So, all these what I was talking about is space segment, that these are the different satellite that we call is the constellation of satellite, I will show you and you will see in the write up that in figure 1 probably or 2, I have shown the different constellation of the satellite. There I will explain a little bit about the constellation of satellite. So, these satellites are moving in a fixed orbit, and the second segment that we call is a first segment was a space segment, second is a control segment. As I said, there are 3 segments of the GPS system, GNSS system. In the control segment, what we have different control stations which are scattered in different parts of the world. Initially, there were 3 control stations, and the master control station is at the Colorado Springs in United States of America, and there are other 2 control stations. What do we have? Apart from this control station, there are other stations, and the job of these stations, control station, other station, is that is another diagram figure, that is probably figure 3, in which I will explain little bit more in detail how they are distributed, how they are located. So, the control station, what they do, they try to track the movement of the satellite, how they are moving, they are about the health of the satellite, about the position of the satellite, and so and so. So, it is the main job of control station is to track the satellite movement, because this is very important, and is health of the satellite. The moment they get some problem, they activate another satellite and deactivate the satellite which are having some problem. And the third is the user segment. User segment, that precisely means we and you, those who are using the satellite data, So, what we have, if you want to do any project, for that you need to have certain data. So, for that you need to have a GPS system, that is that we call is a GPS receiver, and as per your need and requirement, you go and to the field to particular area and collect the data. That I will talk about little more in detail. So, this is in short 3 segments. Now let us talk something more specific details about the satellite. Each satellite, GPS satellite, each satellite has three things. One is a computer, within the computer CPU and all. Then we have the atomic clock, and third is antenna. Now what we have? Let us talk about atomic clock. Now let me tell you also, this system is a two-way system. What does it mean? As I said, these are satellite in a space and we are standing here. We are standing here with a GPS receiver. Signals travels from the GPS satellite. It strikes a particular object. Object means where I am standing a particular object near to an object with the instrument, and after striking this, it goes back. The signals goes back. So therefore, it is called as a two-way system. So what it does in a scientific way and technical term, that this satellite try to calculate the time of signal which travels and comes back. So what we have in a physics, we have a very simple formula, that is a velocity, speed and time. So if I release any signal from here, if it strike that building wall and it come back. So what do you know? You try to know the time which travels and strikes and it come back. So we get the time. We already know the speed, at what speed my signals are traveling, and the distance. Once it strike, the time and distance you get. So therefore, based on this, what we get to know? We get to know the specific target which are under investigation, the object which are there. So what we have? This two-way system. So for that, why I am talking this? Because for that you need to have a very precise clock, and that is called atomic clock. What all we have, like I am having a clock, is a quartz clock where the accuracy is very poor. But if we talk about the atomic clock, it's very precise, very accurate, and it is so accurate you will be surprised to know that accuracy is to a third million of a second. Third million of a second. That means for a layman, if I divide a second into million part, so third of that is the accuracy of this atomic clock. Because it's so precise, it has to be precise, because what we have, the satellites are, as I told you, at altitude of about 20,200 kilometer above the surface of the earth. If we have a even part of millions of a second variation, so distance and the location and the precise location of a particular object will be disturbed. So therefore, these are the three component: computer, atomic clock and antenna of each satellite. So let us see the figure 1, as I told you about the space segment, what all is there and how it looks like. Through diagrams I can explain you in a better, and you will have a better understanding for that. Figure 1 clearly explains GNSS architect. The first one is on the top, that is space segment, where we have GNS satellites which are there. Then we have the GNS broadcast signals, which you see in the form of arrow, and the bottom left is the control segment, that is segment 2, where we have data uploading station, master control station as I said before, and the base station. And the third segment, that is the user segment, where we, you and all that are there. So if you see this figure, GNS architect, as I said that this system is a two-way navigation system. So through this arrow, if you see from satellite, it travels, signals travels to the earth station and it travels back to the control station and then to the user. Now friends, let us see figure 2, which is GNSS space segment, that shows precisely the constellation of a satellite. As I said that there are 6 orbits which are there, and in each orbit if you see a small bird like appearance, that is nothing but is a satellite, that is the space segment. So, if you see this diagram, that clearly gives you an impression that satellite are continuously moving in its fixed orbit at a fixed speed, at a fixed velocity, and so and so. The third segment is Gns Control Segment. So, dear students, if you see figure 3, that gives you a very clear idea about control segment, that is third segment. As I said that there are different control stations, and the most important is a master control station, which is located, if you see this diagram on the left side of it, Spring Colorado, which is at the Air Force Station of United States of Defense. Now, there are other stations, control station, say for example Hawaii, located at Ecuador, Uruguay, South Africa. Then we have the Australia, then we have the South Korea, United Kingdom, Greenland. On the left top is Alaska, and so and so. And to receive the signals, we have different ground control antenna. As I said that satellite has three important components: computer, antenna, and the third is a clock, which are there. So, ground antenna, if you see that, again the very big and the largest ground antenna is Cape Canaveral, Florida, and another is Diego Garcia, and then other is in the Pacific Ocean, that is in the Kwajalein Island. So, these are the ground control stations. So, friends, let us understand the measuring criteria of GPS. That we can understand in a better way by studying the table 1. That gives you different component. So, let us see table 1. So, dear students, let us move further and try to understand and compare different GPS systems. As I said in the beginning, that GPS systems are being launched and being operationalized by different countries, and the first and the most important, and that was started by United States. Then later on it was started by Russia. Then another system that was started by European Union, European countries. So, the GPS system or GNSS, which was started by Russia, that is we call is GLONASS, and the European Agency GPS system is called the GLONASS. So, what we have, let us compare and understand different system that is being operationalized today by different countries, and that we can understand the technical issues in a better way by understanding, by seeing the table 2. So, table 1 shows measuring criteria to measure the performance of GPS satellite navigation system. Now, if you see measuring criteria, there are 4 measuring criteria. One is precision, second is integrity, third is continuity, and fourth is availability. Now, if you see the precision, what it exactly means? It is the difference between the actual position and the calculated position, speed or time of a receiver. Second, integrity is the ability of system to give confidence threshold with alarm in the occasion that inconsistency produced in the positioning data. That is, what are different integrity? That is inconsistency that is produced in acquiring the data, that is the integrity. Third is the continuity. The functional ability of the navigation system without obstacle is the continuity. As I said before, that you get the data without any obstruction in continuation throughout day and night all the year round. And the fourth last is availability, which precisely refers to which the signals accomplish the precision, integrity and continuity criteria during time percentage. That means what are different signal that is being available and to whom which is available, because I will explain little later that these signals are not available to everyone. There are different signals that I will show you in table 2, that signal L1 and L2, and apart from that there are different codes which are available to selective people, to the defense people and to civilian people. So, friends, from table 2 we can see a comparison of various GNSS system. Now, in the third column we have the GPS system by United States of America that we call as GLONASS, that is called NowStar GPS, and in the fourth column that is system that we call as GLONASS, that is designed and developed by Russia, and the third is the Galileo, which is designed and developed by Europe. There is another system of China that we call as Beidou. Now, if you see the characteristics, say for example, GPS system of US, orbital height is 20,180 that I told you before. GLONASS is 19,130 kilometer above the surface of the earth, and so and so. In nutshell, all these satellites systems are placed at an altitude of above 20,000, around 20,000 kilometers. The orbital time is for GPS USA is 11 hours 58 minutes, Russian 11 hours 16 minutes, something like that. And as I said that number of satellites, there are 24 satellites. In NowStar GPS, in GLONASS there are 24 satellites, in Galileo there are 22 satellites, and the Chinese satellite there are 30 satellites. Now, if you see the frequency which is being received by different satellite system, so the NowStar USA GPS satellite system, as I said, there are two signals, one is L1 and L2. L1 frequency has 1.57542 gigahertz and L2 has a frequency of 1.2276 gigahertz. The GLONASS system has a frequency of about 1.602 gigahertz in SP and approximately 1.246 gigahertz again in SP, and Galileo has a frequency of 1.164 to 1.215 and so and so. So, you can have a detailed understanding by going through this table about the frequency. Now, if you see the status of these satellites, so what we find that, as I told you, the full operation capacity was achieved in 1995, and that is the fully operational NowStar GPS US. Russian satellite is operational, but there was a problem when the Russia was disintegrated. This operation of GLONASS GPS system was put to halt, and then again it was started. Galileo, there are about 8 satellite additional operation and 22 satellites which are already there. And then if you see the number of orbits, as I said that NowStar GPS there are 6 orbits, in other satellite system we have 3 orbits. So, basically what all we are using the data is the most commonly data of NowStar GPS. So, therefore, I explain little bit more about the NowStar GPS orbits and all. Orbital inclination, as I told you before, that NowStar GPS is 55 degree, others have 64.8, 56 and something. Now, satellite masses, the NowStar GPS is has a weight of 11,000 kilogram, others have about 1400 kilogram, 625 kilogram and so and so. So, this is about the comparison of different satellite. So, friends, by now we were trying to understand and compare a different GNS system that has been designed and developed by different countries, USA, China, Europe and Russia. Now, let us see that there are different signals, as I was talking about a little bit before, that signal L1 and L2, signal L1 and L2. So, these two signals are commonly available for the civilian uses which do not have such accurate signal. For that, there is another signal that is called the P code, that is precise code. What is done that the P code is encrypted on the signal N1 and L2 both. So, once the P code is encrypted on these two signals, and if we receive the signal by using any instrument, if you are using simply L1 and L2, the accuracy of getting locational coordinate of any object will not be so accurate. But the moment you use a P code encrypted on L1 and L2, the precision becomes very good. That means you can get the precision up to even millimeter. So, imagine getting a data of any object so precise, and therefore, this system was designed by the military purposes for military people for the military purposes to get the precise location of any target during warfare or otherwise. So, what we have that the P code is available for the military purpose, not for the civilian purpose, but it can be also available to the civilian purpose based on the proper requisition, and if the United States gives the permission and so and so. So, that is another issue about the getting the data and all. Now, let us talk in the last part of this today's lecture about the errors and accuracies of GPS. Errors and accuracies. So, errors which we commonly encountered while acquiring the data, that is human error, that depends on various factors. Number one, the signal what we are using, the instrument what we are using, what channel we are, how many channels signal GPS receiver we are using, and what is the threshold value, what is the precision of that instrument. So, that is another there, and what is the compatibility of that receiver to use, whether it is compatible to use L1 signal, L2 signal or both, or even the P code. So, what the agency do is they encrypt this P code with the Y code, and therefore, you are not allowed to use that signal. So, there are different issues which are involved. We do not have time much, so I am not talking detail about the errors. Now, let us talk about the accuracy. Accuracies are nothing but simply that how accurate you are getting the data, and for that to have a better accuracy, you need to have different issues that need to be taken into consideration. Now, as I said that we need to have at least 4 satellites, we need to get the signal from 4 satellites. If you have more number of satellites, better will be the data. So, you have to be very careful, very careful that you try to capture the data once you are having more number of satellites which are logged to your GPS receiver. Say for example, if you have a satellite which has a capacity of logging 12 satellites at a time, you cannot have more than 12 satellites. There are various satellites which can log 18 and so and so. So, if you have a better GPS receiver which can get the data from more number of satellites, so what you will have? You have a better and more accurate data, number 1. Number 2 is called the DOP. I write it here, DOP is a common word that is called the dilution of precision. There are different DOPs. One is called GDOP, then is the PDOP, then is the VDOP, and then is the HDOP. Now, what I am trying to explain to you is that is very important, the dilution of precision, general dilution of precision, second is positional dilution of precision, third is vertical dilution of precision, and H is horizontal dilution of precision. What does it mean? As I said that we get the data in terms of X, Y and Z. So, horizontal dilution of precision, how accurate, how close you are in terms of X and Y. Vertical, that is in the form of altitude. Then positional, in overall position, how accurate you are collecting your data of a particular object and so and so. And last and topmost is the general dilution precision, which speaks about overall positioning of an object. Now, let me tell you one more thing, that if you use any instrument, GPS receiver, on the display unit like a mobile, on the display unit you get some values, and that is called the DOP, dilution of precision. The lesser the number of value of DOP on your GPS receiver screen, better is the data, that is more accurate data. So, there are certain instrument which has a capability of receiving data of not more than not less than 4 meter, but there are certain receivers which has a potentiality of receiving data of less than 1 meter accuracy. That means if I say 1 meter DOP or 5 meter DOP or 6 meter DOP, that means if I am standing here and if the accuracy drop value is 5 meter, that means I am away 5 meter in terms of x or y from that particular object. And for that, what we can do is, in that case we can use differential GPS, that we call as a DGPS, for have a better data collection, differential GPS. In short, this is another topic, detailed topic. Let me tell you in a couple of sentences that the differential GPS, what we have, we make one earth station, one reference station rather, and one is rover. So one GPS is fixed at particular point which is precisely known. So with reference to that, we take another GPS and we keep on moving in the field and collect the data. So what we have, the error what we get on the reference station, the same error we get on the rover, that we call is a rover, the second GPS. And once in the post processing data analysis, we can reduce this redundancy and then we can get the better and more accurate data. That is another way of. So there are many issues that can be taken care of. Another issue is that if you want to have a better data, so you need to stand at a place where you should not have any disturbance of the signal. That means if you are trying to acquire any data, you should not below any high tension line or any building which are there which reflects multi-dimension the signal, and that we call is a different errors and all that can be included in the error, that we call is a multi-path error. That means the moment we start getting signal from different sources, so that disturbs the signal which is being received by the GPS satellite, GPS receiver, sorry. So therefore we need to be careful while capturing the data. If you stand on a particular object, you should try to see if there is no hindrance, there is no tall building, there is no high tension wire, there is no magnetic element, and so and so. So therefore what you can get the more accurate and more better data. So friends, I do hope that in last half an hour I have tried to explain you the GNS system and what are different components, how they are being used, what are different technicalities, what are different signals, how they are being used, what are different frequencies, how to capture our data in a better way, what are the different segments, what are different segments which are there in a global positioning system, for what all these are being used, and the application of GPS and GNS system is another big topic. So in nutshell, I have tried to give you an overview of the satellite system because it was talking about the satellite system. I have also tried to talk about the comparative analysis of different systems of US, Russia and Europe. So through this module and through this lecture, I am sure that you could be in a position to understand what is this system and how they are being used. Maybe you can ask if there is another system that is being developed and designed by India that we call is a Gagan. So let me make you clear that Gagan is not a GPS system for getting any precise location of any object. It is similar of that GPS system, but it is designed and developed by Indian Space Research Organization and Indian Airport Authority, which try to monitor the movement of the aircraft and all for the landing and takeoff, for easy and better landing and takeoff. So it is another system, but don't get confused GPS with the Gagan system, but it is similar of that, but the uses are different. So in the end, I must say that in this module you have learned a lot about GPS system which is being used in the common day-to-day life by different people. What we see today in the different caps are moving, that is precisely by the based on the GPS system. You must have seen caps, you have the GPS system in your mobiles that gives you the location of the particular place, it tells you we are standing at a particular place. So all these are linked with this GPS system. So thank you very much for your patient understanding. Thank you.